All right, welcome guys to Business Math. This is section 1.1. We will be covering linear equations and inequalities. All right, so this could honestly just be an algebra review, but we will introduce the cost function and revenue function, which is important in this class. So we will introduce those in these sets of notes. Okay. Let's first get started with solving linear equations. So a linear equation can be written in the standard form as ax plus b equal to 0, where the coefficient a cannot equal 0. If the equal symbol is replaced by an inequality, less than, greater than, less than or equal to, greater than or equal to, then it's called a linear inequality. Solving an equation or inequality means to find its solution set. And the solution set is what makes the equation or inequality true. Okay, so our first 4 examples are solving linear equations, and some properties really fast, some things we know, maybe you forgot, is that when you solve an equation, you will add something, and if you add something, you add it to both sides. Or if you subtract something, you subtract that quantity to both sides. So basically, you're moving it from one side of the equation to the other. So that's what we're doing, from left to right or right to left. And same thing here. Each side of a given equation is multiplied or divided by the same non-zero quantity. So essentially on equations, it's what you do to one side, you must do to the other. That's all these properties are stating. Okay. So let's go ahead and clean up. First, we'll start with number 1. We will clean up the left side and right side. So here we go. Okay, so first thing we want to do on this problem is distribute the -2 on the left side. So we'll have 3x minus 4x plus 10 equal to, now distribute the 2 on the right side. 2x plus 6 minus 8. Okay, now combine like terms, and the like terms I see on the left side, 3x and -4x. So you'll get -x plus 10 equal to, and like terms on the right side, 6 and -8, you'll get 2x minus 2. Okay. And now we want to solve for x. So go ahead and move x to a side of your choice. I'm going to take, let's see, I'm going to put my x's on the right side because I like my x's to be positive. So I'll say add x, and in the same move, I'll say add 2, add 2. So that's gone, and what we're left with is 12 equal to 3x. Then divide by 3, and x equals 4. There we go. Okay, excellent. There's the first one. Now the second one. Okay, this one involves fractions. Yay, right? You guys love fractions. So here we're given x plus 8 over 4 minus 2x plus 3 over 6 equal to 4. Okay, so since we don't like fractions, let's go ahead and get rid of them. And in order to get rid of these fractions, we want to get rid of the denominators. So to get rid of your denominator, you can multiply by a common denominator. And the common denominator between 4 and 6 happens to be 12. So 12 is the common denominator. So this means that we're going to take 12 and multiply it to both sides of this equation. So just rewriting everything to be neat. So we're going to multiply both sides by 12, which means that this 12 is going to distribute to both terms. Okay. So let's go ahead and distribute it. And here's what we end up with. 12 times x plus 8 over 4 minus 12 times 2x plus 3 over 6 equal to 48. Okay. Next, we're going to do some reducing. 12 over 4. That's the first fraction we can get rid of. 12 over 4, well, that's just 3. So this becomes 3. Oops. This becomes a 3, and that becomes a 1. So what we have is now 3 times x plus 8 minus, and now you have 12 and 6. That 6 becomes a 1. That 12 becomes a 2. You get 2 times 2x plus 3 equal to 48. Okay. And now it doesn't look as bad. We have no more fractions, which means let's go ahead and solve for x. Let's go ahead and distribute the 3, and let's distribute the negative 2. So 3x plus 24 minus 4x minus 6 equal to 48. Combine like terms. 3x, negative 4x, negative x, and then 24 and negative 6. That is a positive 18 equal to 48. All right. Now we'll say subtract 18, and negative x equals 30. Therefore, x equals negative 30. Because on that one, you can multiply or you can divide by negative 1. Okay, that's how we handle fractions. We get rid of them, right? Get rid of them. Okay. Next one, more fractions. Here we have m thirds minus 4 equal to 2 thirds. Okay. So we can go with the same trick here. We can get rid of the fractions since we don't like them by multiplying by a common denominator. Well, here, this denominator is 3. This denominator is 3. Therefore, my common denominator is 3. So let's go ahead and multiply both sides by 3. Just rewrite everything to be nice and neat. All right. And again, distribute this 3 to both terms. And when I do that, well, I'll do it step by step for you. This becomes 3 m over 3 minus 12 equal to, now for this one, we can go ahead and say that this 3 and that 3 cancel. So all we're left with is 2. And now, again, cancel. This 3, that 3, gone. So here's what we're left with. M minus 12 equals 2. Add the 12 over, and we get m equals 14. There it is, done. All right. All right, last one for linear equations. And of course, more fractions. The more fractions, the better. That way you'll love them, right? Okay. All right, so look at our denominators, 4, 3, 2. The common denominator between all these 4, 3, and 2 is going to be, let's see, 8, 12, 12. So we'll multiply both sides by 12. So put 12 there. You have y over 4 minus y over 3 equal to 12 times 1/2. Okay. Now, distribute to both terms. And like I said, I'll do this step by step for you. So you'll get 12y over 4 minus 12y over 3 equal to, but on this one, well, 12 times 1/2, half of 12 happens to be 6. Or we could say this 12 and that 2 becomes a 1, that 12 becomes a 6. Okay, and now time to cancel more. 12 over 4, that becomes 3. So we get 3y minus 12 over 3, that becomes 4. So we get 4y equal to 6. Clean it up. Negative y equals 6, and therefore y equals negative 6. All right, not bad. Yeah. So next is solving a formula for a particular variable. So we want to solve for a specific variable. Okay, so we're given this formula, A equals P plus PRT. This is called the simple interest theorem, which you'll see later on in chapter 3. Okay, so on this formula, we specifically want to solve for R. We want to get R by itself. Okay, so with that, I'll rewrite it. A equals P plus PRT. And our job is to solve for R. Okay, which means to get R by itself means that we need to isolate PRT. So if we're going to isolate PRT, the first thing we should do is move over that single p that you see there by itself. So we're going to take this p and subtract it to the left. And what we'll end up with is a minus p equal to PRT. Now, to get R by itself, you have to realize how PRT is held together. PRT is held together by multiplication. And the only way to negate multiplication or to undo multiplication is to divide. So all you have to do here is divide by PT. That's it. Just divide by PT. And this will give me A minus P over PT equal to R. There you go. We have solved for R. All right, so it's very important to know how to rearrange a formula. Okay. Let's try it again. But this time we want to solve for P. So I'll rewrite it. A equals P plus PRT. Okay. So in this one, we want to solve for P. So we want to have P all by itself. Well, what we see right now is that there are exactly two P's on the right side. There is a common variable or a common factor of P. And I just said the key word here. To get P by itself, well, we are going to have to factor it out. And hopefully you have factored before. If not, if this is something new, don't worry, we'll work through it. But I assume you guys know how to factor already. So since P is the common factor that is showing up, that is what we're gonna factor out of the right side. So here we get A equals, and I'm gonna factor this P out. So I'll put it in red. I'm taking this P out. And if I factor this out, all that's left is 1 plus RT. 1 plus RT. That's all I did. All I did was factor it out. If you want to check your work, take this P and distribute it back in. If you distribute it back, guess what? You're right back here. P times 1 is P. P times RT is PRT. Therefore, it checks out. Our factoring is correct. Okay. And now, all we have to do now to get P all by itself is notice again that P is connected to the parentheses by multiplication. So again, to undo multiplication, all we have to do is divide. So let's go ahead and divide by 1 plus RT. 1 plus RT. What we are left with is A over 1 plus RT is equal to P. And there you have it. We have P all by itself. There you go. Awesome. Ooh, so colorful. Okay, So those were linear equations. Now we'll move on to linear equalities. Okay. So for linear inequalities, we have a couple of properties. Number one, an equivalent inequality will result, and the sense or direction will remain the same if each side of the original inequality has a number added or subtracted to it and is multiplied or divided by a positive number. So if you remember with inequalities, if you divide by a positive number, or if you add or subtract a number, the inequality will stay the same, meaning it doesn't change position. Which brings us to number two. An equivalent inequality will result, and the sense or direction will reverse if each side of the original inequality is multiplied or divided by a negative number. So now if you remember inequalities again, if you multiply or divide by a negative number, the inequality will change direction, or the inequality will switch. That's it. Those are our properties. Okay. Next, the double inequality, which is written as A is less than X and X is less than B, means that A is less than X and X is less than B. This means that X is in between A and B. All right. So now let's get into some notations. All right. So we want interval notation, set notation, and how to represent it on the graph. The first notation, you see parentheses AB, okay? Parentheses AB. In set notation, so this is something called fancy set notation, right? This says, let's see, make it bigger, there we go. I can write over it. So in this fancy set notation, we say for all values of X such that, so again, to start it over, for all values of X such that A is less than X and X is less than B. Close fancy brace. So this notation is called set builder, and it means the same as interval, which is parentheses A, comma, B. Okay. Now, if we were to graph this on a number line, it would be represented just like this, as you're seeing on the screen. Parentheses A to parentheses B. This graph represents the set of X values we can use given by that inequality. That is it. Okay. Next is bracket. Bracket AB, right? All right, so what is the difference between parentheses and brackets? And you're about to see right now, once we go to our fancy set builder notation. So, fancy brace, and again we say for all X, so for all X values, such that A is less than or equal to X, and X is less than or equal to B. Now, do you see the difference between both sets? If you're thinking that the first set is just less thans, you are correct. If you're thinking the second set is less than or equal to's, you are also correct. So what we see about this is that parentheses get less than or greater than symbols. Brackets get less than or equal to or greater than or equal to symbols. So that is the big difference between parentheses and brackets. Okay, now let's see how it is graphed on the number line. And again, there's the difference. Bracket A all the way to bracket B. Okay, so there's also some other things to note here, right? So we know that parentheses, right? Parentheses, let me do that, mean less than or greater than. And what this also means is that the number is not included. Now, which means that if we move to the bracket, brackets mean less than or equal to or greater than or equal to. And you got it right. This means that the number is now included. So parentheses, less than, greater than, not included. Brackets, less than or equal to, greater than or equal to, numbers included. That's as simple as we can put it. Okay. And now the other following examples are just showing you that you can combine parentheses and bracket sets. Parentheses A, bracket B means that for all values of x, such that A is less than x and x is less than or equal to B. And now look at the number line. Parentheses A all the way to bracket B. And so forth. Next is parentheses A, comma, infinity. Well, if you ever see this notation, this means that for all x, such that x is greater than A. Because if it's A to infinity, this means that all your values of x are greater than A, which means they're headed towards infinity. Which means let's look at the number line. We start at parentheses A, and we go all the way to infinity. That arrow is pointing towards infinity. Do we know what infinity is? No. We just know it's a really large number, right? Okay. Which means the same with the other notation. Bracket A, comma, infinity. This means that for all values of x, such that x is now greater than or equal to A, which means that A is now included. On the one above it, A is not included. On this one, A is included. And no matter what, it is still headed towards infinity. All right. And then for the next one, we have negative infinity to B, to parentheses B, and then negative infinity to bracket B. So I'll go over those real fast. Negative infinity to B means that for all x values, such that x is less than b. So this means all the x values are less than that value of b. So look at this. So now we start at negative infinity, we come up the number line, and we stop at parentheses b. All right, and then same thing here. Negative infinity to bracket b means that for all x values such that x is now less than or equal to b, which means that the only difference from this one and the one above it is that b is included. So there it is, negative infinity to b, bracket b, which means it's now included. All right. And maybe you've seen this notation before, maybe not. Negative infinity to infinity, parentheses only. We never put brackets on infinity because we have no idea what infinity is. All right, and then this says, for all values of x such that x is a real number, meaning x can be any number it wants from negative infinity to infinity. Yeah, I'll close that. And now, looking at the number line, we have negative infinity to infinity, meaning we get to use whatever numbers we want on that number line. And that is how interval notation works. Okay, I think the main thing you should take from this is what parentheses and brackets mean. Parentheses mean not included, brackets mean included, and also the inequality that follows with it. All right, don't worry, we'll get some practice down below. So, first up, write the interval, bracket -2, comma 3 parentheses as a double inequality and graph. Okay. So what they're giving us right now is interval notation. So all we have to do is put this into set notation. So we're going to say for all values of x such that -2, and now here's where we follow the actual bracket in parentheses. Since there is a bracket on the -2, we're going to say -2 is less than or equal to x. And since there's a parentheses on 3, we're going to say x is less than 3. Close fancy brace. That's it. That's all you have to write. Okay. And now it wants us to graph it. So I'll draw my number line. I'll plot my two numbers. First up is -2, and -2 will get a bracket. That's how we will represent it. So I'll say bracket -2, and 3 will get a parenthesis. And that's it. There you go. That's graphed. Okay. Next, write x is greater than or equal to -5 in interval notation and graph. Okay. So they want interval. So x is greater than or equal to -5. This means that all my x values have to be greater than -5. And look at this, greater than or equal to. So this means that we're going to start with a bracket, and since the values have to be greater than or equal to -5, we start with -5, and if we have to be greater than, we are headed towards infinity, and infinity gets the parentheses. Okay. Number line, we'll start with -5, which gets a bracket. And we're headed towards infinity, which is over here. There you go. Headed towards infinity. Okay. Last one here. Okay. So write -7,4 as a double inequality and graph. Okay. So again, we're going to want set notation. So we'll say for all values of x such that, and -7 has a parentheses. So we're going to say -7 less than x. And then 4 has a bracket. So we're going to say x is less than or equal to 4. Close fancy brace. There you go. Now graph it. We'll start with -7, which gets a parentheses. And we'll stop at 4, which gets a bracket. There you go. And that is interval and set notation. All right. And again, the biggest takeaway is knowing what parentheses and brackets mean. All right. All right. So next on here is solving linear inequalities. All right. It's going to be just like solving the linear equations, except now after we solve, we have to graph the solution set. Okay, so let's get started. And just like on linear equations, we don't like fractions, so let's get rid of them. Look at my denominators, 2, 2, and 5. The common denominator between 2 and 5 happens to be 10. So we will multiply both sides of this inequality by 10. So let's do that. 10 times x over 2 minus 3 greater than 10 times 3/2 minus x over 5. Okay, so hopefully we don't have to do the step-by-step anymore. So let's try this out. Save us some time. 10 times x over 2 means 10 divided by 2. So this means we'll get 5x minus 30 greater than, distribute that in, 10 times 3 over 2 means 10 times 3 is 30. 30 divided by 2 gives me 15. Minus 10 times x over 5 means 10 divided by 5. So you'll get 2x. Okay. Now time to move things left and right. I'll put my x on the left, and I'll put my constant, my number, on the right side. All right, so I'll say plus 30, plus 30. And in the same move, I'll say plus 2x plus 2x. All right, which means that 30 is gone, that 2x is gone. And here's what we are left with. 7x greater than 35. 30, not 35. 45. Okay. Excellent. Now, just divide by 7. And we get x is greater than 45 over 7. And now let's go ahead and graph that. And 45 over 7. It's a good thing we're in business math, because we can work with decimals. So 45 over 7 is approximately 6.43. So let's go ahead and put on the graph. We see that it only has a greater than symbol. So this means that we will put a parentheses at 6, or I'll make it 45 over 7. And if our x values have to be greater than 45 over 7, or if our x values have to be greater than 6, we are headed towards infinity. And if you did not know, the interval notation would be 45 over 7 to infinity. Okay. Moving on. Oh, thank goodness. This one looks easy, right? All right. So let's go ahead and solve this one. We'll get x by itself, which means we'll subtract 8. So minus 8, minus 8. And we get negative 2x less than negative 4. And then we'll divide by negative 2. And now something's going to change. Since we divide by a negative on this inequality, the inequality will flip. The inequality will switch. The inequality will reverse, whatever you want to use. So we'll say x is greater than 2. Okay. And I will put this in interval notation first, so maybe the graph makes more sense. So for interval, x has to be greater than 2, and it's only a greater than, which means that we'll have parentheses 2, and we will head towards infinity, because all the x values have to be greater than. Okay. Number line, we'll plot 2 down. And again, we are headed towards infinity. Okay. Awesome. There it is. All right, still going. All right. 2 left on these ones. Okay. So now we are going to solve a double inequality. All right. So here it says negative 16 is less than or equal to 5 minus 7x, which is less than 12. Okay. So our job is to solve for x, so we need to get x by itself. So the first thing to move is going to be that 5. Since it's a double inequality, we have to subtract 5 on all 3 parts. So we're going to say minus 5, minus 5, minus 5. And of course, those 5s are gone. And then negative 16 minus 5 is a negative 21. Less than or equal to negative 7x less than 7. Okay. And now to get x by itself, we will divide by negative 7. Divide by negative 7, divide by negative 7, divide by negative 7, and here's what we have. And also, we are dividing by a negative, which means your inequalities will flip. So you'll get positive 3 greater than or equal to x greater than negative 1. There's our double inequality. Okay. Now, if you wanted an interval, well, we always start with the lowest number. Even though it's written a little differently, it still means the same, right? So we start with the lowest number, which is negative 1. And you see that negative 1 has the greater than on it. So we're going to have parentheses negative 1, comma, 3, and 3 has the greater than or equal to. So you're going to put a bracket. Okay. And now graph it. Parentheses negative 1, bracket 3. All right, cool. There it is. Looks a little weird, I know, but it's exactly the same thing we've been doing. Just make sure whenever you divide or multiply by negative, you will flip that symbol. Okay. All right, let's try it again. So solve this double inequality. Subtract 3, subtract 3, subtract 3. We get negative 6 less than 2x less than or equal to negative, nope, sorry, not negative 3, 2, 6. Negative 6 less than 2x less than or equal to 6. Okay. And then divide by 2. We end up with negative 3 less than x less than or equal to 3. And then our interval, it's going to be parentheses negative 3 to 3 bracket. Our graph parentheses -3 to 3. There you go. Okay, cool. So that is solving linear inequalities. All right. Now we move on to applications. All right. There's some steps to help you solve an application. I mean, they're helpful with word problems because, yes, like it says there, we all love word problems. Well, welcome to Business Math, a class full of word problems. Well, except for the 2 pages above, right? All right, step 1, introduce a variable for the unknown quantity. We usually call that variable x. Identify the quantities in the problem. Know what numbers the problem's giving you. Write a verbal statement and equation if possible. Solve the equation, answer the question. Check your answer, become a word problem master. In business math, of course, right? Okay, so if those steps help you, cool. Maybe I'll use them, maybe I don't. Who knows? All right. So the examples we're going to be dealing with are going to be in the form of a break-even analysis problem. So this means that any manufacturing company has a cost and revenue. A company has a loss if revenue is less than cost. A company will break even if revenue equals cost. And a company will have profit if revenue is greater than cost. All right. So first thing we introduce is the cost. Costs always involve a fixed cost. And this could be the expense for production, and it does not change with the number of items. So fixed costs could be anything from turning on the electricity, from sending out delivery trucks, from ordering the products you need to make the products you need in order to make your product, right? So that could be the fixed cost. And then variable costs are the costs that change depending on the number of items produced or sold. So we need to make X amount of items plus the fixed cost of producing X amount of items. So our fixed costs will never change, right? Who knows what our fixed cost goes to? It goes to a lot of things. Like I said, marketing, production, gas, everything. Employees, all that is cost. Okay. So, and then the one thing not shown here is revenue. Maybe I'll write that in. I'll write that somewhere over here. Revenue is always the number of items times the price we sell those items at. So the number of items times the price, which could be represented as X times P. Okay? Excellent. So, okay. So, how many DVDs would a multimedia company have to make and sell to break even if the fixed costs are $48,000 and the variable costs are $12.40 per DVD? And the DVDs are sold to retailers for $17.40 each. Okay, so our goal is to find out how many DVDs we need to make. Nobody even sells DVDs anymore, do they? Oh well. All right, outdated, right? All right, so our goal here is to find out how many DVDs it takes to break even. So to find that, we need to know the cost and the revenue function. Because if you look above in the big old paragraph above, to break even means revenue equals cost. So that's what we're going with first. So let's go ahead and find out what our cost function is. So remember, cost from the above is always given as a fixed cost plus a variable cost, which means that all that's given in this problem. What are the fixed costs to make these DVDs? And the fixed costs are given as $48,000. Plus, the variable costs are $12.40 per DVD. Well, what variable could represent per DVD? Every DVD. What is the variable we like to choose the most? That variable is X. And there's your cost function. Your cost is $48,000, which is the fixed cost, plus your variable cost, which is $12.40 per DVD. Okay. Next, we need to figure out what is the revenue. And revenue is given by the number of items times the price. Okay, well, look what's given here. The DVDs are sold to retailers for $17.40 each, right? So this means that we know the price, which means that revenue would be $17.40 each. What variable could represent each? And again, that is X. Okay. So now we're almost there. To break even, we must set revenue equal to cost. Do we have a revenue function? And do we have a cost function? And that answer is yes. Set them equal to each other. So revenue is $17.40x equal to cost, which is 48,000 plus 1240x. And all you have to do now is solve for x. That's it. Solve for x. So I'll say minus 1240x and this will leave us with 5x equal to 48,000. Uh-oh. My iPad may have lost connection. Hang on. Let me pause for a second. You're like, thank goodness. Okay, we're back. All right. So now I'll divide by 5. And I get x is 9,000. Whoa. 600 DVDs. Okay. So in order to break even, we must produce 9,600 DVDs. Okay. Awesome. All right. So that's how we set up a break even. We set cost equal to revenue. All right. So this next example is just like break even. It's set up in the same form, but it's not in, it won't look like a break even problem. All right. So an employee of a furniture store earns a base salary of $2,500 per month plus a 10% commission on sales over $7,500. How much must the employee sell in 1 month to earn a total of $5,000 for the month? Okay, so we want to set up an equation for the employee's salary. Like, what are they going to make plus commission? So we're going to say salary. So no matter what, this employee will earn $2,500, no matter what. If they sell 0 furniture, this employee still will earn $2,500. So guess what that's a fixed cost or a fixed amount. So 2,500 plus. Now the next part is tricky. It's the commission part. This employee will make a 10% commission on sales over 7,500. So this means that whatever they sell over 7,500, you'll multiply it by 10%, and that'll be part of their salary. Okay, so to set that up, we'll first put the commission. .10, which is the 10%, times, all right, so they need to sell over 7,500. So we don't know how much they're going to sell, and since we don't know how much they're going to sell, what variable perfectly represents something we don't know? If you guessed it, X is correct. So this employee needs to sell X amount of furniture, but their sales must be over 7,500. There you go. Looks a little tricky, but X minus 7,500 means that X is the amount of furniture the employee is going to sell, and it has to be over 7,500 in order to make a 10% commission. Okay, and now this employee wants to make $5,000 for the month. So we're going to call this one paycheck. And for their paycheck, this employee wants a $5,000 paycheck, no matter what. They want to sell enough furniture to make $5,000 for the month. Okay, well, this is just like break even, right? Except they don't want to break even, they want to make money. But it's in the same terms. I told you it would look a little bit different. Okay, so all we're going to do is set the salary equal to the paycheck. And this employee's salary is given by the equation 2,500 plus 0.10 times X minus 7,500 equal to the salary, the paycheck they want to make of $5,000. So all we have to do now is solve for X. So first thing you're going to do is distribute that 0.10. So we distribute the 0.10. And then we'll combine like terms on the left side. And we'll get 0.10x plus 1750 equal to 5,000. And then subtract 1750 you'll get 3250. So 0.10x equals 3250. We'll move over for some more room. So 0.10x equals 3250. Then you'll divide by 0.10. And in order for this employee to make a $5,000 paycheck, they must sell $32,500 in furniture sales. And working at a furniture store, that's not hard to hit. What? One couch set, a table, an ottoman, what's that, 5 to 10 grand, depending on what you want. This employee's got to be easy. They can make more than $5,000. All right, so that's how we solve that one. Whew. Okay, almost there. All right, last one. Oh boy, it looks long, right? It's not too long. It's just like the first word problem we did. All right. The publisher of a new book figures fixed cost at $51,000 and variable cost at $1.30 for each book produced. With this pricing, 2,882 books need to be produced and sold at $19 each for the publisher to break even. However, rising prices for paper require an increase in variable cost to $1.80 for each book produced. What strategies might the company use to deal with this increase in cost? Find different suppliers to try and lower the variable cost, increase the font size of the print in the book, increase the selling price of the book, and decrease the fixed cost. Okay. Well, one for sure that increasing the font size will not do us any good, because if paper is increasing, that'll mean more paper, right? So B is out. All right. All right, what do you think next? Increase the selling price of the book. That actually seems like a good strategy, right? If you increase the selling price of the book, that will help you deal with the increase in cost. So C is good. All right. And then let's see, between A and D, find different suppliers to try and lower the variable cost, or D, decrease the fixed cost. I think it's better to decrease the fixed cost, right? Because the fixed cost is definitely more than your variable cost. Look at your fixed cost. It's $51,000. And your variable cost is $1.80. So with that being said, let's see if we can actually decrease the fixed costs. So we'll say D. So A is out, right? Yeah. Okay. All right. So we'll say C and D are good. I think they're good. Maybe it's A. I don't remember. Okay. All right. So B. If the company continues to sell books at $19, how many books must they sell to make a profit? Okay. So this is for us to know. Okay, so we have to figure out the break-even cost. Okay. So with that being said, let's find out the cost function. And remember, cost is fixed cost and variable cost. So our fixed cost is $51,000. And our variable cost was raised to what? $1.80? Yes, our variable cost is $1.80 per book. So there's our cost. Now let's look for our revenue. All right, so for revenue, it says that these books need to be produced and sold at $19 each. So remember, revenue is items we're selling times price. So our revenue is going to be given by 19x. All right. So with that being said, we're going to want to know how many books to break even. So you'll set, again, cost equal to revenue, or revenue equal to cost, either one. So 51,000 plus $1.80 equal to 19x. All right, and just solve for x. Subtract $1.80. And 51,000 will equal, what's that, 1720. And then divide by 1720. And we will get x equals 2,965.1 books. And this says to round up to the nearest whole book. Oh, my laptop is not cooperating at the end. Okay, let's finish this. Okay, so we get 2,965.1 books. It says round up to the nearest whole book. You know, we don't normally round up 0.1, but as a company, we don't want to make 0.1 of a book. So we're going to try to make 2,966 books. Okay, so in order to make a profit at this new cost level, we're going to have to sell 2,966 books. Okay. And while I took a small break, I went back and found out that, yes, A is correct and D is not correct. Because apparently we can't change fixed costs, even though I don't believe that. Because we could always choose a different marketer, a different delivery company, anything like that. So But sure, we can find different suppliers to try and lower the variable costs. Okay. Last one. Okay. If the company wants to start making a profit at the same production level of 2,882 books before the cost increased to $1.80, how much should the publisher sell the book for now? Round to the nearest cent. Okay. So the company doesn't want to make more books, right? They want to make the same amount they were making, 2,882 books. And they want to do this at the new cost level, right? So in order to do this, they want to know, in order to actually still make profit, they want to know how much should they sell the book for now. So this means that they want to do a price increase to keep up with the cost increase at the same amount of books they were making before all this happened. So all we have to do for this one is find the price, right? We want to find the price. Okay. So what we're going to do for this one is we're going to treat it as break even still, but the one thing we don't know is price. So cost is still going to be 51,000 plus $1.80 X. Revenue is now going to be, so remember, revenue is the number of items times price, right? So, well, in this case, number of books times price. Well, we don't know the price because we want to know what could we sell these books for in order to keep up with the cost and still make a profit. What we do know is the number of books. So this means that our revenue is now 2,882 books times P. Okay. Which means that for cost, well, if X represents books here, this means we are also going to plug in 2,882 for X into the cost. So you'll get 51,000 plus 180 times 2,882. And if I type all that in the calculator, let me see, 51,000 plus 1.8 times 2,882, I get 56,187.6. Okay. And now, just like all the other ones, I'm going to set cost equal to revenue. And now my number for cost is there above, 56,187.6. And I'll set this equal to 2,882 P. And all I have to do is divide by 2,882. And with that being said, to the nearest cent, this means that in order to keep up with the new cost and to still produce the same amount of books, 2,882 books, the new price we must sell these books for is $19.50. That's it. That is all. Whew. All right. That's it, guys. Down here is the glossary, basically of everything we've gone over. Go ahead and check it out. But that will end section 1.1. All right, that's it.